Bismillahirrahmanirrahim and Assalamualaikum to our lecturer TS Dr. Omar bin Bapakuti. Today I and my group teammate want to present to you about our project Tabular Level for the topic Torsional Loading Evolution from the Actual Structure. We are from BMMM S1/2. Before I'm going for our presentation, I want to introduce myself. My name is Muhammad Azzamuddin bin Noahdin and my metric number is B09191041. Okay, now let's start with the introduction first. First of all, that we have three introduction. First point is torsion is the twisting of an object due to an applied torque. Second point is torsion is expressed in either the Pascal PA and SI unit for Newton per square meter. And the last point is in section perpendicular to the torque axis, the resultant shear stress in this section is perpendicular to the radius. Okay, now we're going to the objective for this assignment. First, to draw detailed FBD from actual structure related problem. Second one is to develop equilibrium equation from the FBD drawn. And the last one is to analyze force member from the structure. Okay, on this assignment project, we choose tabular level log, or normal name is door handle. For we make the experiment to relate with the torsion chapter to see how the torsion work for twisting the tabular level log. For part calculation in this experiment, we use a few of formula torsion to calculate. First, to calculate the available stress, maximum force that will fail to the structure, and the last one is we also calculate the factor of safety.
Hi, my name is Muhammad Azrikimi bin Abdul Halim. Now I will share with you the real picture of tabular level log. And now I will share with you the 2D drawing. I've been prepared of front view, side view and top view. For the dimension, length 1 is 289 mm, length 2 is 542 mm. For the radius will be 59 mm, and for the diameter will be 118 mm.
Assalamualaikum. My name is Muhammad Razi Adam bin Rahman. Metric number B0919100012. And today I will explain about the calculation. We will start about the free body diagram. So this is the free body diagram. With the length of the handlebar is 542 mm and the force of 79 Newton apply, and 64 mm is the radial distance from the midpoint to the outer surface. So next we gonna go for the calculation with equation of equilibrium with assumption of fx equal to 0, assumption of fy equal to 0, and assumption moment equal to 0. There is no force at the x-axis, so the fx is equal to 0. Assumption equals to y, and the only force that had in the free body diagram is Fa, which is 79, which is Fa in the y-axis, and the assumption of movement equal to 0. Moment is equal to force time by distance, is force Fa time by the distance time by perpendicular distance, which is 79 times by 542 times 10 to the power of negative 3, which is time by 10 to the power of negative 3 because change the dimension into meter. So we got the torque value, which is 42.82 Newton meter. So next we need to find the torsional force which is the formula is torsional force equal to torque time by radial distance from center to the outer surface divided by polar moment of inertia, which is J. J is the unknown, so we need to find the J, which is polar moment of inertia, by the formula equal to pi multiplied by radius to the power of 4 divided by 2. So we gonna get the answer, which is 2.635 times 10 to the power of -5. By we get the value of polar moment of inertia, we can sub into the torsional force formula, which is we can get the answer of 104,003 Pascal. So from the equation, we need to predict the factor of safety, which is the factor of safety formula is T max over T allowed, which is we need to find both T max and the T allowed. First of all, we need to determine the internal torque, which is from the equation of torque plus force multiplied by distance, which we need we get the internal force, which is 65.65 Newton meter. From that, we can get the torsional force max value, which is 159,453 Pascal. With the value, we can sub into the torque max, which is the formula is torsional force max multiplied by polar moment of inertia over radius, which is we get the value is 65.65 Newton meter. So after we calculate all the torsional force value, we can sub into the factor of safety formula, which is torsional force fail over torsional force allowed. So we can get the value is 1.53. As long as the value is between 1 and 2, the structure is not fail. Thank you.
Salam sejahtera kepada Dr. Omar dan rakan-rakan sekalian. Okay, today I'm in front of you all to present about our project. That was the dog knob. So in my part, I want to present the discussion of the dog knob. So in the stimulation, we analyzed that was many of the force that acting to the use of the dog knob. So when the length also the main character of the to estimate the force of the strain in the dog knob. So we analyze, we do the calculation all in our before editing. So in my version, I want to identify one thing about that the strain, stress and all the force is estimated by the original length of the material. So when the most strain in the force, so the more shear in the force, and then when the when the more like steel, wood, like that, so the shear, the force and then the strain also based on the material manufacturing method. So we have calculated with the original lengths of all the materials. So we discussed the theme. So I think this all from me for the discussion, and then bye bye.
Hi, my name is Weldon Anna Andre and my matrix number is B0919100123. Today, I would like to present to you about the conclusions of experiment project. In our conclusions from this experiment project, we are able to analyze the deformations of circular shaft when subjected to torque. Apart from that, we also learn about the test method to obtain the shear modulus of elasticity for materials and how to calculate the factor of safety that object. Besides, an increase in either the loss or the distance from the loss to the center will result in an increase in the shear modulus of elasticity. Last but not least, the objective of this experiment project have been achieved. So that's all from me and my friends. So thank you so much for your interest and attentions today. See you next time. Bye.